In the last video, we saw the sampling theorem, and now in this video, we will see the quantization and how to sketch the discrete time signals. So, if we are given a signal x of n, which is given as -5, -2, 3, 0, 4, -2. So we will sketch this signal as this is a discrete time signal. So here we will consider the origin as -5. This is the origin. We will consider this as the origin. First term is considered origin. Okay. This is -2, 0, 1. This 3 comes at 2. 0 at 3 and 4 at 4, -2 at 5. This is the plot of x of n. This is the discrete time signal graph of x of n. And if we are given the x of n is equals to -2, -3, 0, 2, 4, and if in the question an arrow is added, so this arrow represents the origin of the signal. So this is the origin of the signal. This is at 0. At -1 we have -3. At -1 we have -3. At -2 we have -2. At 1 we have 2. Sorry, this is at 1. This is at 1. And at 2 we have +4. So this is the graphical representation of a discrete time signal where we have uh, different plots, two different plots we have seen. If arrow is not given, then we will consider the first signal as the origin of the signal. First term is the origin of the signal, then it will continue likewise. And if an arrow is given, then this will be the origin of the signal, and the next term will be the this is the on the negative half of the waveform, and this is on the positive half of the waveform. Now moving on, and uh, we try to solve a question on sampling. Okay, so here a question on sampling is given as a continuous time signal x of t is 2t minus 1, which is sampled at a sampling time of 2 seconds. Then the discrete time signal x of n is given as, so we have x of t as given as 2t minus 1. X of t is 2t minus 1, and the sampling time is 2 seconds. So we will replace this t. We know that in sampling, this t is replaced as nts, where n is the number of samples and ts is the sampling time. So we have t is equals to n2 because t as sampling time is equals to 2. Now we will replace t with nts. So we get 2 into n2 minus 1. So we have x of nts is equals to 4n minus 1. So if we put the different values of n, we will get the discrete time signal. We can plot the discrete time signal x of n. Now x of n will be, let's put 0. If we put 0, we get minus 1. At the origin, we have minus 1. If we keep minus 1 here, we get minus 4 minus 1, which is minus 5. Minus 5 at the position minus 1. If we put minus 2 here, then we will get minus 8 minus 1 minus 9. If we put 1 here, then we will get 4 minus 1 3, which is at position 1. Here we get 3 at position 1, and at position 2 we get 7. So this is the form through which we can plot the discrete time signal from a signal x of t, and how to convert a signal continuous time signal to a discrete time signal. Okay, now let's continue. With our the process of adding two signals. Suppose we have an example. We have example where x1 of n is given as minus 2 3 0 5 2, where we have 0 as the origin, and x2 of n is given as 1 2 3. So these are the two signals. Okay, so when we add these two signals, let's see what we get. When we add these two signals, so this is the origin because here no arrow is present, and here an arrow is present. So when we add, this minus 2 is added with 0 because this is the origin, and in the left of it we have 0. So minus 2 will remain same, 3 will remain same. At the origin 0 is here, and here 1 is here. So we will get 0 plus 1 1, with this is at origin, and 5 plus 2 we get 7, 2 plus 3 we get 5. So this is how we add two signals, add two discrete time signals. Now when we multiply them, these two signals, we get minus 2 is multiplied with 0, 3 is multiplied with 0, this origin, 0 is multiplied with 1, 5 is multiplied with 2, and 2 is multiplied by 3. So we get 0, 0, 0. This 0 is it, which is at the origin. Now 5 into 2 we get 10, and 2 into 3 we get 6. So this is how we multiply and add two signals. Now we have zero crossings. We have a concept called zero crossings. So what does this zero crossings basically mean? Okay, zero crossings are the points where signal, these are the points where signal changes its amplitude, changes its amplitude from positive to negative, from positive to negative, and negative to positive, and from negative to positive are known as zero crossings. These zero crossings necessarily represents the phase reversals. Zero crossings represents phase reversals. Phase reversals of the signal that takes place at the points of zero crossings. So this is the concept of zero crossing. Now we will come to the digital signals, and we will see what is the definition of digital signals. So what basically are digital signals? The signals discrete in time and amplitude. Discrete in time and amplitude are called as digital signal. Okay, so these are the digital signals which are discrete in time and amplitude, and continuous time signal where continuous in time and amplitude, continuous in time and amplitude. The discrete time signals are discrete in time, discrete in time, but continuous in amplitude. So we have digital signals, continuous time signals, and discrete time signals represented as they are. Now we see the process of quantization. What is basically quantization? Quantization is the process of changing or converting signals from continuous time to digital signals. Quantization is the process of converting signals from continuous time to digital form or digital signals. We have two types of quantization process. One is the unipolar quantization. In unipolar quantization, we have two polarities, which is in the form of ones and zeros, 1 1 1 0 0 0. So these are the unipolar quantization process, and the bipolar quantization process. And in the bipolar quantization process, we have only ones or zeros. So if we write ones, every value will be only one. So this is bipolar quantization. So these were the basic definitions of continuous time, discrete time, and digital signals. We saw two numericals here, and in the next video we will see the standard signals, which are unit impulse signals. So stay tuned, and we will continue with the unit impulse signal.